Hello and welcome to the Malti-Kulturali Xjenza Teknoloġija program. In today's episode, we dive deep into the world of manufacturing, automation, and robotics. Please welcome our special guest, Professor Michael Saliba.
Thank you.
Thank you for joining us today. So, starting off with our first question, can you give us some details of what a typical day looks like in working in this field?
Right. Well, as an academic, days are very interesting and quite varied. So a typical day might start with a 2-hour lecture, for example, perhaps in the first year. So there'll be a large class of some 70 students. And later in the morning, perhaps a board meeting or a committee meeting, boards of studies, etc. So these are academic things that happen at university. But the most interesting parts are when I have to deal with robotics projects that my students are doing. So typically we'd have master's and PhD students as well as final year undergrad students doing projects involving robotics. And they'll be working in the lab, so I'll have meetings with them, suggesting what to do next. They'll be showing me what they've done, things that have worked, things that may not have worked, etc. So it's all very exciting, and when we have good results, we can even write papers and publish them in conferences or journals, which kind of disseminates the information, so it's very interesting. Yeah.
Okay. What type of robots do you normally work with?
Right. Now, this is an important question, actually, because I think from the outset we have to distinguish between two different types of robots, and I work with both. So there are industrial robots, that are the robots that are fixed, that they work in industry and that they'll be doing things like welding, for example, assembly, etc. These are the ones you might have seen videos of robots building cars, for example, a car assembly. Those are called industrial robots. Then there's a different class of robots called service robots, which are robots that are outside the factory. And they're beginning to become more popular now. So robots that might be helping the elderly, for example. Or those Roomba, those cleaners, those vacuum cleaners, those are a type of robot, actually, because they've got a complex program and they've got a strategy on how to clean the ground.
Okay, that's very interesting. Mm-hmm. So following to the prior question, what are robots made up of? Do they have a mechanical brain? What type of materials are they used to conduct the machine?
It depends now a lot on what type of robot it is. But typically a robot has some sort of a skeleton. So if it's one of those fixed robots, you'd have links joined by joints between them, okay? So robots always have some sort of a structure, a skeleton. Always motors, because robots move. It's one thing robots do, they move. And sensors to sense either where their own joints are or to sense something in the environment. The brain, they always have a controller, so something to tell them what to do. But of course, how that controller works depends on what the type of robot is. It could either be programmed and it will do exactly as it is programmed, or else it could use AI these days as well to kind of figure out, rather than what to say, like ChatGPT does, but what to do now.
Yeah.
Okay? Yeah.
Sounds very technical.
Okay.
How do they function and receive commands?
Right, okay, so if it's a typical industrial robot, it's got a controller, it's actually a computer, but it's a computer that's specially made for the robot. And there'd be a program written, the controller would be reading kind of the program, interpreting it, and if a program says to the robot to move to a certain position, then the motors there's a mathematical calculation, because you give the program tells the robot move to X, Y, Z, so to such a place. But then the robot has to figure out where to put the joints so that the actual end effector, the gripper, goes to that point. So it does that calculation, but then just commands the motors to go to the respective correct position. So it's kind of the controller is telling the robot what to do.
Okay. What are the biggest challenges in robotics today?
Well, robotics in industry is a pretty mature field. So actually they matured in the 70s and 80s, and there's only been small improvements, kind of. So those are already very mature. But the biggest challenge today is to have a robot, for example, that can help you in the home. Because the home is very cluttered, not like a factory where everything is exactly where it should be. And the challenge is to actually be able to deal with the unorganized, the disorganized environment of the home. The chair could be in the way today, the mug could be placed in a different place. And if you want a robot to help you clear the table, it's not a simple process.
Yeah.
So that's the challenge.
Okay. So do robots work independently in this field, or do they have to have supervision from a human?
Okay, so a robot always has supervision in whatever it is. Like, we don't want robots to be taking over and taking major decisions. If it's a robot in industry, it's been programmed, so you don't actually need to have a supervisor anymore, because if it's programmed, it's going to do exactly what you want it to do every time. If it's a robot in the home, if it's a complicated humanoid robot in the home, which we haven't seen yet, okay, then of course there's going to it's got to be clear that it's got to obey the instructions of whoever owns it and whoever wants it to do jobs. Okay, so yes, that's important.
Okay, well, thank you very much for such remarkable and intelligent responses. We will now conclude of the first half of the interview, and we will now showcase our 2 to 3 minute feature regarding the topic of automation.
Robots are becoming an increasingly common addition to modern workplaces. In manufacturing automation, robots are designed to carry out multiple tasks in a more accurate, efficient, and safe way. Robots are very reliable and work continuously without exhaustion. These robots are designed to do the work of multiple people at once. They use their high-tech capabilities to receive instructions and follow commands. From cars to electronics, they are responsible for building the products we use daily. In manufacturing, robots may be tasked with retrieving and relocating parts from one area to another. Doing so will prevent any injury that may be inflicted on human employees, as they avoid lifting heavy and dangerous equipment themselves. Robots may also be tasked with welding and assembling metal parts together. They can evenly paint multiple surfaces and inspect the product's quality and deformities using high-tech cameras and sensors. As mentioned earlier, physically demanding jobs such as heavy lifting can now be done in half the time it would require if done by a human. Chemicals, paints, and dangerous fumes may also be handled by a robot rather than a human. Doing so reduces many health risks and improves workplace safety. In automotive plants, motor vehicles such as trucks, cars, motorbikes, and others are designed and built and assembled. The vehicle parts undergo multiple processes and results shown are high quality and polished. Jobs that require extreme precision may also be done easily and produce identical results with the help of robots. Overall, robots will continue to develop and increase the quality of life among many people. With these improvements, we hope to see a large reduction in factory accidents and a surge in product quality.
And we're back. So, going based off the feature, what improvements have you noticed thanks to the implementation of these machines? Is there an increase in productivity or in consistency?
Yes, of course. So in industry, there's an increase in both productivity and consistency, in quality especially. So today, when you have companies that are making something in the thousands and in hundreds of thousands, it's important that everything is according to specifications. And clients of these manufacturers typically want, for example, one failure in 2 million product. Okay, so you have to be very, very consistent, and humans typically can't be that consistent. So robots definitely improve quality and consistency a lot. Yes,
okay.
Definitely.
Another question: what happens when a robot makes a mistake or breaks down? Does the operation stop completely, or do the human employees replace the robot temporarily?
Right. Now, okay, so I have to see how the robots would have been implemented in the company. So typically, a company would first have people doing the manufacturing, and then they decide, okay, we're doing well, the business is doing well. So they would install robots. But the cell is still kind of human-sized. So a good thing there is that if the robot breaks down, it could be possible that you temporarily replace the robot with a human. But more typically, rather than doing that, they have contracts with robots, with technical firms that can repair robots fast. And, you know, they would phone in an urgent way, we're down, you know, production is down, can you please send us somebody in the next hour, 2 hours to fix it? So typically they try to get the robot back online as soon as possible.
Okay.
Yeah.
So what's something people misunderstand about robots?
What's something people misunderstand about robots? Okay, there's science fiction that always kind of scares us that robots are going to take over the world, you know, become too smart and take over the world. Today there is a concern with AI, that AI can become dangerous. And if you are going to link AI now, but rather than just giving you answers in a computer to something that can hurt you and that can do damage, maybe that's something that would scare people. But the industry is very well controlled and there are many safety features. So in fact, I don't think that's something that people have to worry about. However, I would tell you this. If somebody hacks your computer at home, the worst thing that can happen is that you lose all your data. It's very bad, it's serious. But if you've got a humanoid robot at home and somebody hacks that robot, it's not just losing data. It could actually, you know, break things, etc. So this is something that is a big concern to the manufacturers of these humanoid robots, how to now make them hack-proof and limit the damage that can happen if they are hacked.
Okay. Which industries would you say are using robots the most right now?
Okay, traditionally, the car manufacturing industries are the ones that have used robots the most, I would say, since their inception. So they remain, I think, the largest users globally. But all companies that build parts, for example, in Malta, I've got a few large companies that make, for example, automotive switches. It's still in the car industry, okay, but it's not building the car, it's building a switch, or electrical components. So a lot of companies that make mass-produced components, they use robots. And of course, we are using robots when we've got those vacuum cleaners. We are also, you know, the people out there are using robots perhaps without knowing it in a sense as well.
Yeah. Do you think this is a popular topic to be chosen amongst students?
I know that it is a popular topic to be chosen among students. Actually, robotics kind of is exciting. Right? It's something that is avant-garde. I mean, you're dealing with this interesting technology. So, in fact, one of the study units that I teach is a 4th-year study unit, and it's selective. So that means people choose it if they are interested in that area. So in the first 2 years, they have to take all the study units, but in the last 2 years, they can choose what interests them. And the robotics class is always one of the ones that's very popular to be chosen. So yes, I think there is a kind of attractiveness of robotics, and even on brochures of exhibitions in the faculty, the front page of the brochure is very often a robotics-related picture because it's something that attracts.
What advice would you give to students wanting to pursue this as a career?
Okay, well, assuming they like physics and maths and they've entered engineering, so that would be the starting point. It's an engineering topic, although to be fair, robotics is multidisciplinary, and you can even be a computer scientist and do robotics from that end. But if it's from engineering, you would choose subjects like mechatronics, for example, which is a subject that links mechanical engineering and electronics control systems. So you'd start by choosing those subjects that lead you to robotics, and then choose a final year project that is related to robotics, because that gives you a big kick-starting then into your future career. I'm in robotics because my final year project in engineering was a robotics project, actually. So very often people then keep on building on the expertise from their final year project. You don't have to, but it's easier if you do it that way.
Okay, that was amazing.
Okay.
And with that, we will conclude our episode. Thank you, Professor Michael Saliba, for joining us and teaching us about the process involving automation. Thank you for tuning in, and we hope you learned something new. Goodbye.